All right, in today's worksheet that I gave out today in class, we're going to go ahead and go through 1 through 12. Now, on number 1, it says y equals 3 secant theta. And the first thing we're going to do is graph y equals 3 cosine theta, because remember, the secant of theta equals 1 over cosine theta. So we're going to graph the cosine first and then make our parabolas very last. So when we look through this, we always want to write out what is our amplitude. Our amplitude is the number that's in front of the cosine, so our amplitude is 3. To find our period, we take 2 pi divided by omega, which is the number in front of theta here, which is 1. So it's 2 pi divided by 1, which is 2 pi. We don't have anything added inside the function, nor do we have anything outside the function, so that's all we have. Now, remember that's going to be 2 pi times 0, 2 pi times 1/4, 2 pi times 1/2, 2 pi times 3/4, and 2 pi times 1. Give us 0, pi over 2, pi, 3 pi over 2, and 2 pi as our 5 points within the period. So we'll be at 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, we didn't have a vertical shift, so our midline will stay right there on the x-axis. Now, we did have an amplitude of 3, so that means from the midline we'll go up 3 and down 3. I like to circle that number so it reminds me of where my top amplitude point and my bottom amplitude point will lie. Now we look back and I've got to graph the cosine. Now remember, the cosine function will start at our starting point at the top amplitude. Then the next point it hits our midline. Then we go to the bottom amplitude, midline, and top amplitude. We connect our points by curving through the points because it is a wave. Now we need a graph in our asymptotes. Now our asymptotes are going to be everywhere that the midline and the point of the graph crosses. So we'll have one at pi over 2, and we'll have another one at 3 pi over 2. Now to graph the cosecant function, what we will do is we will take our maximum endpoints here. We have a maximum, and we make our parabola. We have a minimum. We make our parabola within our asymptotes. We have another maximum, and we make our other parabola. Now, remember that to graph this truthfully all the way through, we would need to go and erase away our cosine function, and we would just be left with our half parabola here, our full parabola down here, and our top parabola half here, going on one period from 0 to 2 pi. Now we're going to graph number 2, y equals 2 secant theta. Now remember, secant theta goes with 1 over cosine theta. So we're going to graph the cosine of this function. So y equals 2 cosine theta. Now the number in front of the cosine, remember here, is our amplitude. So that'll be 2. To get our period, we take the number that's in front of theta. We take 2 pi divided by that number, which is 1, which gives us 2 pi, and that is our period. Now, just like in number 1, we're going to have our 5 points as being 0, pi over 2, pi, 3 pi over 2, and 2 pi. Again, there is no number on the outside beyond theta being added or subtracted, so our midline will stay on the x-axis. So that'll be our midline. Now, our amplitude is 2, so that means we have to go up and down an amplitude of 2 from that midline. Now it is the cosine function again, so we're going to start up at our top amplitude for our first point. Our second point, we hit our midline. Third point, bottom of our amplitude. Next point, midline, and last point, the top of our amplitude. We connect them by curving through them, and that gives us one period of our cosine function. Since we need the secant function, we need to draw in our asymptotes again at wherever our cosine function crosses the midline. So here's our asymptotes. Now we need to make in our parabolas. At this maximum point, we go towards our asymptotes on each side. And that gives us our secant function, except for we need to take our eraser and go through and erase away our cosine function, because we do not want that part of our graph, and then fill in our sketch so we can have y equals 2 secant theta. Now for number 3, we have y equals -3 secant theta plus 1. We need to change this over to a sine or cosine function to graph it. First, remember the secant. We're going to use y equals -3 cosine theta plus 1. Again, labeling in our amplitude, which is here. So our amplitude is 3. Our period, again, is going to be 2 pi, because the number in front of theta here is 1. And remember, it's 2 pi divided by 1. Now, outside our theta, we have a 1 out here. That's going to be a vertical shift. Because it is positive, we'll have a vertical shift of up 1. Now, let's go ahead and graph what we have here. So I'm going to go ahead and graph my vertical shift up 1. Now remember, our midline on our original function starts at the x-axis. Moving up 1 puts us up on the line y equals 1. Now we have an amplitude of 3. So going up 1, 2, 3, down 1, 2, 3 gives us our top amplitude and bottom amplitude. Our period again is 2 pi, so we'll be at 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, remember here that we have a negative sign out front. So instead of starting at the top amplitude, we will start at the bottom amplitude. So when I graph this in, we start at the bottom amplitude. Next point, we hit our midline. Top amplitude, midline, bottom amplitude. And again, we curve through the points because we are a cosine function and we are a wave. Now again, our asymptotes are going to lie wherever the cosine function hits our midline. So we'll have one at pi over 2 and another asymptote at 3 pi over 2. Again, we need to draw in our parabolas. Now, the black line that represents the cosine function, remember, that's a cosine function. That's not a secant function. So we need to take our eraser and erase away that cosine function, which helped us graph the secant function. And we're left with the graph that looks like this. Now, as we graph number 4, y equals 2 cosecant 2 theta. Now, remember, cosecant goes with the sine, so we're going to graph y equals sine 2 theta. Now, remember, our amplitude here is going to be 2. Now, our period is 2 pi divided by omega. And remember, omega is that number in front of that theta. So it's going to be 2 pi divided by 2, which is going to give us pi because the 2's are going to cancel out. Now that's going to change our points on the graph. Now putting it into our table, our period is pi. And remember, we always multiply that by 0, then 1/4, then 1/2, then 3/4, then 1. So that'll give us 0, pi over 4, pi over 2, 3 pi over 4, and pi. And those will be our 5 points on one period. So we'll have 0, pi over 4, pi over 2, 3 pi over 4, and pi. Those will be my 5 notches, or my 5 x points. Now, there was no vertical shift, so our midline still is on the x-axis, and that's going to be, remember, the midline. Now, the amplitude is 2, so that means we need to go up 2 and down 2 from that midline. Now, we're graphing the sine. Remember back to the parent function of the sine. The sine starts at the midline. Then it goes to our top amplitude, which is 2, and our bottom amplitude, which is going to be -2. So we start at the midline. Next point, we go up to our top amplitude, then back down to our midline, then down to our bottom amplitude, up to our midline. And remember, it's going to be a wave, so we need to curve through each point. Now, we're not graphing the sine, we're graphing the cosecant. So we need to put in our asymptotes. That's everywhere, just like with the cosine graph that we graphed for the secant. The cosecant works the same way. Wherever those points hit that midline is going to make an asymptote. That's not going to change. Now we take our max and min points, and we make our parabolas. We take our eraser, and we erase away the sine function, leaving us just with the cosecant function. And if you notice, our points here of our parabolas are going to be the same spot as our amplitude, the top amplitude and the bottom amplitude, leaving our asymptotes, our midline, and our parabolas. That gives us y equals